In this chapter, we've used random number generation to create several different arrays. And in this first exercise, I'd like to use an array to examine the distribution of the numbers that the random number generator creates. In other words, how well spread out are the numbers from the range that we've asked for. So to do that, we're going to create an array of numbers that runs a range of 0 to 100. Then we're going to create a second array called distrib that will store the total of each number shown in the first array. If that doesn't make sense to you now, it will when I create the distrib array. So the first thing we need to do is pound include the libraries we need for random number generation. So we need cstd lib and then pound include ctime. Now let's create a function to build an array. So the parameters are the array and the size of the array. Because we're generating random numbers, we need to seed the random number generator, so we'll do that first. Then we're going to build the array using the standard technique we've used throughout the chapter. So we'll write right here, array sub I is equal to rand modulus 100 plus 0, because we're going to run the range from 0 to 100 instead of 1 to 100 as we did in most of the other examples. We're finished with that. Now let's create a second function that initializes an array to zeros. We're going to need that for the distrib array, and I'll explain why in a minute. But first, let's build the function. So we'll call it init array. Its parameters are the same as the build array function above. And this time we're simply going to loop through the array and set each element to a 0. We're going to use this function after we create the distrib array and initialize each element of the distrib array to 0 before we go through and total up the numbers from the first array. And finally, as the last function, let's write a display array function. And for this function, we're going to display the index position of the array and the element in that position on a single line. So we're going to write our loop like so, as we've done for every other example. I less than size, plus plus I. And then right here, we're going to write cout I for the array position, followed by a colon, followed by the element stored in that position, and then a new line. Because we want to be able to see clearly what the elements of the array are. Now that we've written our functions, we can get into the program itself. So the first thing we'll do is create a constant for our size, and it's going to be set to 101 because we're going in the range from 0 to 100 as opposed to 1 to 100. Let's create our first array, numbers. It's going to store the numbers that we're going to generate randomly. So once we've declared it, then we can call the build array function with the array name and size to build the array of random numbers. Now let's write out a new line and then call the display array function with the numbers array so we can see what's actually in the array. Let's write another new line. Now we're going to create the distrib array. Each element of the distrib array will represent a number in the numbers array from 0 to 100. The way the distrib array works is each time we find a number in the numbers array, we will increment the corresponding index position of that number in the distrib array by 1. So for example, if we find 2 number 1s in the number array, then distrib sub 1 will be equal to 2. You'll see when we run the program. So to build the distrib array, we'll write a for loop in the body of the program. That runs through the distrib array and looks at the numbers array to determine what to increment by 1. That's the key line right there that I just typed in. Each time from 0 through 100, we'll look at the element in numbers sub I and increment it by 1. So that, again, if we have two number 1s in numbers, then distrib sub 1 will be equal to 2. If that's still not clear, it will be when we display the array next. So we'll do that next. Display array distrib with size, and then cout and indel, just so we'll be sure to have some space between the different displays. So let's build and run the program. Oops, we forgot to do something, and that's fine. I'm not going to take that out. I forgot to initialize distrib, and you see why. Let me bring that back up again. Let's run that one more time. This is a good teaching moment. Because I didn't initialize the distrib array, even though I planned to do that, we're looking at the values here where my cursor is of displaying the distrib array. And you'll see we just have random values because we did not have 2,293,031 instances of the number 0 in the numbers array. So clearly we're just accessing random memory. So we want to avoid doing that. That's why we initialize arrays, and that's why we created an initArray function. I just forgot to run it. So there we go. Now it's in there. Let's build and run the program again. I'm going to scroll up and let's look at the output first from distrib array. So what it's showing us is that there was one instance of the number 0 in the numbers array. There were 3 instances of the number 1 in the numbers array. There were 2 instances of number 2, 0 instances of number 3, and so on and so forth. Let's just pick one example. Let's look at the number 0. Let's go back up to the numbers array, which is in our first display, and let's see how many times we find the number 0. So far I've seen it 0 times. Scrolling slowly, we may not get all the way to the top. Let's look again. And there's one example right there. So there's 1, 0. We should not see another one if my program worked correctly. Scroll slowly through. There's a 1, but not a 0. Keep going down, still not seeing any zeros. And there we go. So that's how you can use the information from the data in the array. And that's one of the things you'll learn as a programmer is how to structure your program based on the data. So you have a problem. I want to see the distribution of the numbers in an array. Well, because we know that the numbers go from 0 to 100, and that's exactly what our index positions can be in the array, we can use that to help solve our problem. In the next exercise, we'll build on this exercise and create a histogram or a bar chart of the distribution of the numbers in the numbers array.